Alright, welcome back. In this video we're going to now look at the scenario where instead of integrating with respect to x to find the area, we want to instead integrate with respect to y. And there are some scenarios where it's just going to be easier to do it with respect to y. We'll see in our second example would be that we're going to do, it'd be quite difficult to do it with respect to x. A lot of times this happens when you have functions like what we have here, f and g. These are actually two sideways parabolas. And if you're trying to get this area here with respect to x, it's kind of a little hard because you'd have to find these points of intersection, and notice that it's this area between the g curve and itself would be for that part. And for the second part, you'd be looking at the area between the f curve and itself. It's two halves, which would be a little bit of trouble. But when we integrate with respect to y, we can just go straight up the y-axis, and it's just between the two functions. So there's just sometimes where it's just going to be easier to do it with respect to y. And basically use the same idea. We're going to integrate up the y-axis now. And we're just basically, if you took the picture and tilted it sideways, I can't really do that. It'll just flip, unfortunately. But if you took the picture and imagined things going sideways, then your g of y, your f of y function would be the top function. Right? It's further to the right. And your g of y function is the bottom function. And then you're just looking at that rectangle. And so we're integrating f of y, top minus bottom, or in the case of y, right minus left. Okay, so let's see this in an actual problem. So our problem here is we want to find the area that is bounded by y equals x, y equals negative x plus 2, and y equals 6. So I've gone ahead and pulled the graph out. So let's paste that in here and see what we're looking at. So here we have the graph of y equals x here in red, negative x plus 2 here in blue, and y equals 6 here in green. Okay, so what we're looking at, of course, is this area right here, this triangle, is what we actually want to find the area of. And yes, this actually is a right triangle, so you could, if you want it, measure this length here for your height, measure this length here for your width, and then do your area formula for a triangle. But what I want you to first notice is if we integrate it with respect to x, you would actually be going this way, and there's actually two different bottom functions. So we'd have to actually break the integral and do two separate integrals. This integral here, where the blue graph is the bottom one, the top one is the green, and then we'd have to do this one. So it would take two separate integrals. But with y, if we integrate with respect to y here, right, we just need the one dimension, and we can see that this point right here is the point 1, 1. So we're actually going from y equals 1 up to y equals 6. And we're going to integrate the red function, which is the right function, minus the blue function. Okay. And so we do that. Now, when you do this, we do have to make sure our equations are written as functions of y. So that means we need to solve each of them for x. We need to solve each of those equations for x. So before we put them into the integral form, we do need to solve them for x. Well, x equals y is pretty straightforward. And then the other equation is y equals negative x plus 2. So I need to solve that for x. I can do that by bringing the x over and the y back. And so getting my second equation, x equals negative y plus 2. All right, so now we can start the integral. The integral from 1 to 6 of the right function, which is y, minus the left function, negative y, plus 2. And then this is the integral with respect to y. Okay, so we go through and we simplify. Y minus a negative y is going to make that 2y minus 2 dy. And we integrate, that'll be y squared minus 2y, evaluated between 1 and 6. And then we just do our computation. All right, we just do our computation. And when you compute this, you'll get y squared, which is 6 squared, 36, minus 2 times 6, 36 minus 36 minus 12 would be 24. And then you just continue on with the 1. 1 squared would be 1 minus 2 times 1 would be a negative 1, but it's being subtracted, so it's 24 plus 1 will be 25. So now we've computed the area here. Okay. So this is the first example again of integrating with respect to y.